In this video, we are going to be looking at probabilities of a permutation and a combination. So in our first problem, there are 6 acts in a talent show: a comedian, a dancer, a guitarist, a magician, a singer, and a whistler. The talent show host randomly schedules the 6 acts. Compute the probability of each of the following events. Event A, the guitarist is first, the dancer is second, the magician is third, the whistler is fourth. Event B, the first 4 acts are the guitarist, the singer, magician, and dancer in any order. Okay, so the difference between those is event A, it's in a specific order. Guitarist is first, dancer is second, magician is third, whistler is fourth. On the second one, it has the same people playing, but they don't have to be in the exact order that it says here. So in the first one, the order matters, and in the second one, the order doesn't matter. Okay, so the first one is what we call event A is a permutation, which is an arrangement of things in a particular order. Okay, like this: guitarist first, dancer second, so on. Okay, and this is the formula for it. Okay, so N in this is a permutation with N and K. N describes how many total things there are, so there's 6 total acts. Okay, and K stands for how many you're choosing. Okay, so in both of these, our N is going to, or our K is going to be 4 because we're choosing 4 acts out of the 6. Okay, and this is the formula for N and permutation K. Okay, so on this one, for probability of A, we have that N is equal to 6 and that K is equal to 4. So I set it up right here like this. So the N would be on top, 6 factorial. And on bottom, we would get 6 minus 4 factorial. And 6 minus 4 is 2. So you get 6 factorial divided by 2 factorial. Okay, and then you would get 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, you would get 2 times 1. That's what the factorials are. Okay, so the 2's and the 1's go away. That leaves you with 6 times 5 times 4 times 3. And if you multiply 6 times 5 times 4 times 3, let's see what we get. 6 times 5 times 4 times 3. Okay, 360. Okay, so that is 360. All right, so this happening, that means there are 360 different ways that it could happen, and this is one of those ways. So our probability of event A, that the guitarist is first, dancer is second, magician third, whistler fourth, is 1 out of a total of 360 possibilities. Okay, so our probability is 1 out of 360. Okay, for problem, or the second part of the problem, we have the first 4 acts, but the order does not matter. So this is a combination, a grouping of things for which the order is not important. Okay, so notice it's almost the same formula as up here. It's just got this extra little k factorial down there. Okay, so everything else about the problem is going to be the same. N is still 6, that's the total number of acts. K is still 4, that's the number of acts we're choosing out of the 6. Okay, so this is the formula we're going to use. So it'll be N factorial, which is 6 factorial, N minus K, so 6 minus 4 factorial, and then K factorial would be 4 factorial. 6 minus 4, let's do that in the next step. So 6 factorial on top, 6 minus 4 is 2, so 2 factorial, 4 factorial. Okay, and now I can write the top like this: 6 times 5 times 4 factorial. Instead of writing it all out like that, I can just stop at the 4 factorial, because I know that on bottom, I also have a 4 factorial that will cancel out. Okay, and for the 2 factorial, I wrote 2 and 1. Okay, so you end up getting 6 times 5, which is 30, and over 2 times 1, which is 2, which is 15. So your probability of this event happening is 1 out of a total of 15 possibilities. 1 out of 15 is your answer on that. Okay, let's try another one. There are 10 streets to be named after 10 tree types: ash, birch, cedar, elm, fir, maple, oak, pine, spruce, and willow. A city planner randomly selects the street names from the list of 10 tree types. Compute the following probability. Event A, the first street is fir, followed by the pine, and then the willow. So that's order matters: first, second, and third. The second one is still 3 things: the oak, the spruce, and the fir. but the order does not matter. Okay, so in the first one, the order matters, so that's a permutation, and we use this. So how many total things do we have? That's n. The total number of things that we have is 10, and we're choosing 3. 1, 2, 1, 2, 3. So k is equal to 3. So for probability of event A happening, it's equal to n factorial, which is 10 factorial, over n minus k, so 10 minus 3 factorial. That's 10 factorial over 7 factorial. I can write the top as 10 times 9 times 8 times 7 factorial instead of writing it all out, because I have a 7 factorial on bottom and they'll cancel. So I ended up getting 10 times 9 times 8, which is 720 if you put it in your calculator. So there's 720 different possibilities. This is one of them. So our chances of probability of event A happening is 1 out of 720 different possibilities when the order matters. For the second part, it says that we still have 3 streets, but the order doesn't matter, so we're using a combination instead of a permutation. Okay, the n and the k are the same. We still have 10 total things, and we want to choose 3 of them. So n is 10 and k is 3. We put that in, we get 10 factorial on top. This parentheses gives us 10 minus 7, minus 3, excuse me, factorial. And then the k is 3 factorial. Okay, so that gives us 10 factorial over 10 minus 3 is 7 factorial and 3 factorial. Okay, I'll rewrite the top as 10 times 9 times 8 times 7 factorial, because I know there's a factorial on bottom. It's right there. Okay, and then I have, for the 3, I have 3 times 2 times 1. So let's cancel out the 7 factorials. Okay, and that will give us 10 times 9 times 8 on top and 3 times 2 times 1 on bottom. Okay, so you can either multiply this out and reduce it, or reduce it first. 2 goes into 8 4 times, 3 goes into 9 3 times, so the bottom is nothing but a 1. So we get 10 times 3 times 4. 3 times 4 is 12, times 10 is 120. So our probability of event B happening is one event out of a total of 120 different possibilities. And that's it.